Hey there, and welcome into today's Explainer. As a senior architect, it is literally my absolute pleasure to guide you through this material. You're stepping into a brand new phase of your career right now. You're moving way past the basics and taking on some seriously complex projects. And honestly, that means our approach to development, well, it has to mature. So today, we're focusing on the human-in-the-loop development cycle. We're going to look at that critical judgment layer, basically what you, the human, absolutely must bring to the table when working with these incredibly powerful AI coding tools. Okay, let's dive right into this. Think of our agenda today as our meta specification for this session on professional discipline. First up, the clean code illusion. Then we'll talk about why you must write the blueprint first. Third, we'll cover how to stop, review, and evaluate. And finally, we'll lock in testing as your core professional responsibility. So moving into phase one, the clean code illusion. Look, the promise of AI coding tools is just incredible, right? We get massive gains in speed and scale, and we can bypass so much of that repetitive manual coding. But with all that speed comes a very real immediate risk. There is a stark difference between being just a button pusher and actually being a builder. See, a button pusher just feeds prompts into an AI and blindly accepts whatever pops out without any real oversight. But I need you to be the builder. The builder acts as the director throughout the entire process. If you're leaning entirely on AI without applying your own human judgment, you're basically surrendering control of your own project, and we definitely don't want that. Which brings us to the core of the clean code illusion. Listen to this. Code generated at speed can contain errors at speed. Sometimes these AI tools output code that looks absolutely perfect. I'm talking beautifully named variables, pristine formatting, clean syntax. Because it's built in a way that looks so perfectly clean, you might naturally assume it functions perfectly, right? But underneath all that polish, it might actually be using a deprecated library or totally failing to sanitize user inputs. You just cannot make that assumption. Implementing a human-in-the-loop concept allows for that crucial second set of eyes. It demands a strict trust but verify mentality on literally every single line you didn't write yourself. Consider this a complete redefinition of your job description. The human in the loop is not just a reviewer at the end, they are the director throughout the process. You are there to make those complex, highly nuanced decisions that the tools simply cannot make. You're the one catching those subtle logical errors like, an annoying off by one loop or some hallucinated API endpoint that the tool just cannot see. You have to apply the judgment that no model can replicate. All right, let's move into phase two. Write the blueprint first. Before we even think about executing code, we have to plan. In a really professional human-in-the-loop workflow, a specification is not just some casual prompt you hastily type into a chat window. No, it's a rigorous professional document. It describes exactly what you are building, why you're building it, and within what strict constraints. And this brilliantly illustrates how writing a true specification literally forces you to mentally build the system. You have to think through the entire problem space long before you touch a single line of code. Now, here is your essential checklist. A good specification absolutely requires all of these components. You're going to need a clear problem statement, clearly defined user personas, explicit data requirements, both functional and non-functional requirements, and of course, absolute clarity on security. And I want to be super clear with you on this point. This exact document format is a strict requirement for your upcoming capstone walkthrough. You're going to present this to us before showing us any code whatsoever. Honestly, relying on this rigorous blueprint framework is the fundamental professional difference between just hacking something together and actually architecting a real scalable solution. Hackers, they just start typing and hope for the best. Architects plan, they define the boundaries, and they execute with absolute intention. That brings us to phase three. Stop, review, and evaluate. Basically, avoiding the trap of complacency. So you've got your blueprint, and now we actually start building. But here's the catch. During a long development session, it is dangerously easy to fall into complacency. You start just generating, approving, and moving forward without genuinely evaluating what the AI just built for you. You must schedule review checkpoints. Stop after the data layer. Then build the authentication system and stop. Then the user interface and stop again. Finally, the AI integration. You literally have to pause and verify at every single one of these major component milestones. And at every single one of those pauses, I want you to run through this non-negotiable checklist. Does this component actually do what the specification said it should? Does it interact correctly with the database schema or the auth tokens we already built? And maybe most crucially, are there any new security vulnerabilities introduced by the generated code? We're talking about things like an exposed API key or missing authorization checks. This right here, this is the trust but verify workflow in action. Think of this as your literal litmus test for personal accountability. Ask yourself right now, would I be completely comfortable sitting down in a formal code review and explaining every single line of this generated code to Drew or maybe one of our senior engineers on the Innovative Solutions team? If there is even one block of code where your answer is, I'm not exactly sure how that loop works, but hey, it runs, yeah, that is totally unacceptable. I know this is a hard truth, but it is a core professional maxim for responsible coding. If you cannot explain it, you do not understand it well enough to deploy it. Period. You absolutely must claim ownership over every single character of code that goes into your final build, no matter who or what generated it. Let's move to phase 4 and see how this all builds into professional testing. So, for this final quality assurance phase, I really need you to shift your mindset. Testing is not some victory lap you take when you finally think everything is working. No, testing is a deliberate hunt for failure. It's the proactive process of finding out exactly what is not working. You want to break it in a safe environment, long before it actually matters to a real user in production. For your Builder's Permit deliverables, this right here is your minimum required test coverage. Yes, for sure, test the happy path where everything goes exactly right. But your true professional responsibility lies in those other 3 areas. How does the system handle edge cases? Like, what if a user inputs special characters into a standard search field? Are access controls strictly enforced if a regular user tries to hit an admin endpoint? And crucially, failure handling. What actually happens if a third-party API connection drops right mid-transaction? Does the application crash gracefully, or does it just hang there and expose sensitive stack trace data to the world? Actively simulating these specific failures, that is your job as an architect. So the crucial point here is that you must document all of this. Document your test cases, document those bizarre edge cases you anticipated, and document your actual results. This will form the core of your documentation package for your capstone submission. It's your concrete, undeniable evidence that you took full professional responsibility for the code. To sort of summarize our entire journey today, hackers just build and ship at speed. They let the tools do the driving, and they're completely blind to the risks. Architects, however, take a vastly different path. We definitely use the tools for speed, yes, but we build, test, review, and deploy responsibly. We maintain that critical human-in-the-loop lifecycle from the very first blueprint all the way down to the final test case. I'll leave you with this final thought. You have the tools, you have the framework, and you know the rigorous standard that's required of you. So the question now is, are you ready to step up from being a mere button pusher to becoming a true architect for your capstone submission? Take these lessons, apply them to your workflow, and build something incredible. Thank you so much for joining me in this explainer, and I seriously look forward to reviewing your specifications.